Hello, everyone, and thank you for joining us today. My name is Greg Johnson with Loring Consulting Engineers. I'm also a member of the Illuminating Engineering Society. I'd like to welcome you to our presentation today on deciphering sustainability, understanding the environmental impact of lighting systems. We have a great presentation for you lined up today, but before we get started, I just want to cover a few housekeeping items. At the bottom of your screen, you'll see a Q&A box. Feel free to submit any questions throughout the presentation. We'll address as many questions as time permits at the end of the presentation. And lastly, as a reminder, our presentations are all recorded and archived, so you'll be able to view the presentation again at a later time and share with others. We'll place a link to the channel in the chat as well. And at this time, I'd like to turn it over to Sam Worst to kick off the presentation.
Thanks, Greg. Good afternoon, everybody. Happy Friday. Thank you for taking some time to join us for today's presentation on sustainability. We will be covering the environmental impacts of lighting materials and a design philosophy that puts sustainability first when manufacturing luminaires. Shauna represents Vode Lighting and is the Southeastern Regional Sales Manager. She has a bachelor's in mechanical engineering and an MBA from the University of Florida. She has over 20 years of experience in the lighting industry and has worked for companies such as Lewis Polson, Beghelli, Tempo, and now Vode Lighting. So without further delay, let me introduce you to our speaker, Shauna Spaziani. And Shauna, you can take it away.
All right, thanks, Sam. And thank you, everyone, for spending your lunch hour to talk about sustainability. As Sam mentioned, this is called Deciphering Sustainability, Understanding the Environmental Impact of a Lighting System. And what I hope to show you today is to look at the weeds of what an environmental impact assessment is. These are all standards that are currently being developed right now for the United States for the lighting industry. Right now, our industry is very much behind where, a lot of other commercial industries like textiles are as far as quantifying our sustainability and our carbon footprint of all of our products. And so right now, the lighting industry as a whole, behind the scenes, is developing standards based on what they've been doing in Europe for a long time. So today we will look through a lot of that. We can get in the weeds into this. It can get very technical, but I'll try to keep it a little bit light and to also just keep it focused on what you can learn and as designers and what you can also pay attention to and look for when you're looking at specifications and spec sheets. So we will look at some sustainability frameworks, demystify what those mean and what a lot of the terms that you're probably going to start seeing on spec sheets are. And we'll look at eco-friendly materials that are very commonly used in lighting fixtures, and also what to look for when you're choosing lighting products specifically for those eco-friendly projects. And then finally at the end, we will also review an environmental impact report. And when you're looking at things sustainably day to day, you won't necessarily ever have to see an environmental impact report, but I think it's important for you to understand what goes into the ratings and the certifications that you're going to start seeing on a lot of spec sheets as well. So this is a 1-credit course that is qualified for the AIA and the IIDA. At the end of this presentation, in about a week's time, you can expect an email from me with a completion certificate. And I know that there is a link in this chat as well to put your membership numbers in there. We'll be happy to register any of those. And of course, if there is a typo, if you don't see your registration, if you don't see your credit for whatever reason within about a week, please just feel free to reply to me, and the team at Vode will be happy to square away any records that might be looking a little bit askew for you. Without further ado, though, let's get into the presentation. And first, before we go into the weeds of what takes a certification, let's first look at what designing products for sustainability really looks like. There are 3 key aspects that kind of go hand in hand together. And 2 of those, the lighting industry has been doing for a long time since we started using LEDs. So one is longevity, something that's going to last as long as possible, and something that's as most energy efficient as possible. So those are 2 key aspects that are easy to accomplish when we're looking at LEDs compared to older light sources like incandescent and fluorescent. The other key aspect, though, that is is also equally important when we're talking about sustainability is the recyclability of the fixture and the components that make up the fixture at the end of its life cycle. Like I said, you can look at other industries, and they've been doing this for a long time, but the lighting industry has blissfully been kind of shutting their eyes to what happens to the fixture at the end of its life cycle, after it's gone past its warranty time, after it's taken that 50,000 hours of operation and it's taken down. Right now, we don't really pay attention to what happens to the product, but now we're starting to look at what's called a circular economy. So typically a linear economy, which is where we've been living for so long, is you design a fixture, you make a fixture, you sell it, it gets to a job site, it's operational for 5, 10, 15 years, or maybe longer, depending on where it's installed. But once the fixture is taken down to be replaced by something else in a redesign, most of the time the fixture is just discarded. No one really pays attention to where it goes or what happens to it. And that's very linear. There's no closed loop. So a circular economy is where we're closing that loop off. There are a few key things that need to happen for the circular economy, but basically what it means is at the end of its life, product designers are designing products that can be disassembled. For electronics, lighting products, specifically those that tend to be sealed, like an integral LED lighting fixture, that can be a little bit difficult. So they ask that a product can be designed to be taken apart, all of its parts and pieces organized. Some of those will still go to a landfill, but the idea is that the other pieces that can be recycled are recycled, and they're melted down to raw material, repurchased by manufacturers, and then reused to build new products. And what does that mean? So first of all, the big key there is, again, designing for disassembly. There are a couple of things that have to happen in design that traditionally don't happen for a lighting fixture. One, you can't use a lot of fasteners, screws, nuts, and bolts because they can get lost. They're hard to recycle. They're just hard to keep track of on a job site. And once you have to start unscrewing a lot of things, it's also a big barrier to entry to disassemble a product. The other key thing, though, is you can't use a lot of harmful adhesives either. A lot of glues can't be used, and other chemicals that would typically seal a fixture are now considered taboo. Another thing to look at with LEDs, and it kind of goes with where the trend of the products go anyway right now, is designing for dematerialization. It basically means editing your design down. It's very easy to design a fixture that has all the bells and whistles that you need, from high lumen output to all the optics and precise optics that you want, with maybe rotatability, functionability, adjustability. Maybe it needs to be outdoor rated or needs some special NEMA enclosures. So when you start asking for all of these things, it's easy to build a product that's big and bulky and houses everything that you need. That's how lighting fixtures used to look about 10, 15 years ago for LEDs. But what's very important when we're looking at the carbon footprint, sustainability, and also that circular life cycle is a product that uses the least material as possible, but is also still as powerful as design needs to intend it to be. So weight is very important. I'll show you a chart later in the presentation that shows exactly why this is so important, as well as far as the carbon footprint of the products. But just for that circular life cycle and something that can be disassembled, taken apart, and recycled, using as few parts and pieces as possible and as small of a profile as possible is really key to that sustainability initiative. And it's very difficult. Editing design down is one of the hardest things that you can do, whether you're designing a lighting product, whether you're writing a novel, anything in between. Editing is extremely difficult to do. And finally, designing for longevity. And what we mean here is, yes, we're using LEDs that last a long time, but one of the key things that I always get pushback on, and have since I started selling LEDs a long time ago, was that people didn't like the fact that an integral LED fixture was all-encompassing. So if you have to maintain the fixture, if it breaks, or even at the end of its life cycle, what do I do? How do I replace that, the insides, without having to replace all of the exterior of the fixture as well? And traditionally, the answer for a lot of integral LED fixtures is that you can't. If the fixture is not modular, if something goes wrong, you have to trash the entire thing and buy a new one, and it is so wasteful. So there has to be a balance there when we're talking about designing for sustainability, where you have an integral LED fixture, but it's still designed in a modular way where certain aspects of the fixture can be replaced and a big percentage of the fixture can still stay there. So an example like this, the mounting hardware might be something that could stay installed and only the lighting elements inside would be changed out, but you still would have to maintain warranty, extend the warranties so that the fixture can last longer and longer while just updating the technology inside. So those are important things we're looking at when we're designing fixtures, and some things you can start thinking about as well, what's important when you're looking at fixtures that you're choosing for as well in your sustainable projects. So now we'll look at a couple of guidelines as well. So these are guidelines that some of you may have seen a lot and may be very familiar with. So some of them might be new to you, but I think you're going to start seeing a lot of these on spec sheets going forward. So we'll just go through a few of them here. And the way that this is organized on this page is that you have the standards, certifications, declarations, and material lists. So it kind of goes on a higher level down to a more minute level where the standards, you're probably very familiar with the LEED certifications, that International Well Building Institute that's behind Title 24. You have the Living Building Challenge, which we will talk about today. ISO standards, of course, we're all pretty familiar with those. When we look into certifications, those are kind of those basic requirements where kind of a reward for manufacturers who meet basic requirements. It's basically a stamp on a fixture that says you've done this due diligence. You might have sent it to a third-party testing lab, and now you get this stamp that says that you've done this. Declarations are materialists, are more just ways to promote transparency, but they're not necessarily third-party certifications that require manufacturers to go through a process to then get rewarded. So a few of those, of course, UL you're very familiar with. DLC has been around for a long time, but there might be some new things here that you're not necessarily as familiar with. An environmental product declaration, we'll go through that today. Something like the ROHS, the restriction of hazardous substances, that is very commonly used on the manufacturing side. You may or may not see it on spec sheets. But the few important ones that we will talk about today, the Living Building Challenge, we'll talk about CIPSE. That's a European standard. And again, we're basing a lot of what we're doing in the United States on Europe. And we'll also talk about Cradle to Cradle a little bit. And what we'll talk about next is the environmental product declarations and declare programs. So that also ties into, when you see that material list, that red list approved, red list free. We can also organize these into like a good, better, best, or basic, intermediate, and advanced. I like to think of it as that good, better, best because you have just like a basic standards of just operating a safe fixture. So those would be like the ROHS, a Title 24 over, mainly used more on the West Coast. Those are actually a lot of times just suggestions. Some of them are requirements, but they have a mix of the two. But again, just a very basic level. UL, of course, we're all very familiar with there. A better would be intermediate, and then the advanced would be like the environmental product declarations. So first, let's talk about the Declare program, because you're probably pretty familiar with starting to see a label like this on a lot of spec sheets for your products. Basically, this is a Declare label, and at the top it asks the manufacturers to list the place of final assembly. We'll go through why that's important in a couple of slides. The life expectancy of the product, so how long is this going to last? And the embodied carbon or the carbon footprint of the product as well, if you have it. And then they'll also ask for the end of life option. So how much of the product is recyclable? How much of it has to go to a landfill? And if a take-back program is applicable in your area, and we'll talk about those as well, they also ask for the name and place of the take-back program. Down at the bottom may be something you don't really pay a lot of attention to. You may just see, oh, I have a Declare label there, great, but I don't necessarily know how to differentiate or know to differentiate between the different kinds of Declare that are out there. But this is where at the bottom of that label, they do ask manufacturers to say, are you declared, are you red list approved, or are you red list free? And what does that mean? Because they do mean three very different things. So I'll take you through quickly what that red list is. So when you see it on a spec sheet, what is it and what's the significance of it? So the red list is a list that the Living Building, or the ILFI, the International Living Future Institute, who created the Living Building Challenge, they made this list of about 10,000 chemicals that they considered hazardous to the environment and to people. And it is a ever evolving and growing list that keeps getting updated. So manufacturers who participate in this program also have to keep up to date with this list as well. But basically they say these 10,000 chemicals are hazardous, and do you or do you not use them in your products? So any manufacturer who wants to participate in this program has to do a self-audit of each one of their products. And they have to list all of the ingredients in their products down to 100 parts per million. So that's pretty small. And then they have to basically list them all, publish them all to the Declare program. If they do that, they can put a label on their fixture that says it's red list declared. Basically, we're being transparent about all of the chemicals that are in our product. Now, if we are red list approved, it means that the manufacturer has done that self-audit. They have published a list of all the chemicals and ingredients they use in their products down to 100 parts per million, and less than 1% of those ingredients are included in the red list of hazardous materials. So that's pretty hard to do for manufacturers, but for lighting manufacturers, it is possible to do. But if you see someone with a label that says red list approved, it means that they really went that extra step, and you can consider them a pretty sustainable company. Now the red list free, again, good, better, best. You have the declared, which is good, the red list approved, which is better. The red list free is best. Red list free pretty much, again, means that a manufacturer has done that self-audit. They publish that list of all their ingredients down to 100 parts per million, and none of those ingredients appear on the red list of hazardous substances. Right now, the way that manufacturers and fixtures are manufactured, it's very, very difficult, almost near impossible for manufacturers of lighting fixtures to accomplish a red list free. But they can get red list approved if they go through certain processes. There are a couple of loopholes with this that make the Declare program good, but it's not necessarily the most ideal way for us to measure sustainability of products. So for one, this is just a typical lighting system that you see on the screen, where you have a luminaire, you have a driver that powers the luminaire, and then you have some type of connection that connects the driver and the luminaire together. That's the very basic fixture system for LEDs. And the Declare, the ILFI, knows that most lighting fixture manufacturers do not make their own drivers. So they don't ask manufacturers to break down the ingredients of the driver itself down to 100 parts per million. You can leave that out. This program is all self-audited. You heard me say that a few times, which basically means there's no third party coming through and reviewing their notes and reviewing their testing processes. So it's all based on the honor system. What this ends up meaning is that a lot of fixture manufacturers, just to say, oh, we're red list approved, they will not include the wire harnesses, which again, a lot of common wire harnesses include a lot of chemicals on the red list. So manufacturers will eliminate that. And then because they don't have to, they won't list the driver either. So what that basically means is that a lot of manufacturers will say that they're red list approved, that we don't use any of these hazardous materials in our products, but if they're also submitting and talking about a product that can't even turn on. So may be important to you, may not be, but it's also something to know and to be a little bit educated on when you start seeing those Declare labels on those spec sheets. What does it mean? And if it is important to you, then ask those manufacturers when they're presenting those products to you. Okay, how do you test this? What parts and pieces of your entire system have been tested along with this product to get those red list approved certifications? So we talked about kind of like a good, better, best with the Declare program. Now, again, it's self-audited, it's on the honor system, but it's a good first step. So now I'm going to turn the gear and look at what's called an environmental product declaration. And I won't try not to get into the weeds too much, but this is basically the other end of the spectrum. This is a very thorough analysis of the carbon footprint of a product. It's made up basically of this is calling it a product category rule. In essence, it's just a template that a manufacturer would use to create a life cycle assessment. And I'll explain what that is in just a minute. But that's basically just the impact of a product over its full life cycle. And those are combined to create a transparency report that says, here's the entire impact of this product over the entire life cycle of it. And that life cycle assessment that creates that environmental impact report, it's very thorough. These are all of the different areas that it assesses. So we have everything from global warming potential. I'll show that to you in a graph later on in the presentation. But we have ozone depletion potential, acidification potential. I'm not going to go into detail of any of these. It's just going to be I think a little bit too heavy for today. But what if there's anything I could ask you to take away from this slide is that the life cycle assessment, as far as all of the aspects that it asks manufacturers to test over and account for, it is very, very thorough. And when we're looking at each one of those categories, here is all of the different life cycles that those categories test over. So what you're seeing here is at the very top, material extraction of the material before it is even put into a product, and then the transportation of that material to a factory, the making of the product, the transportation of this product to a site, installation and construction. Then the yellow is all operational use and maintenance. The light green as well. We also look at energy use, the water use, if that's applicable. And then the dark green goes into deconstruction of that job. So at the end of the job cycle, here again, we're looking at that closed life cycle loop. So we're looking at the deconstruction, the taking apart of the product, transportation of those parts and pieces to different areas, whether it's to a landfill or it's back to a recycling facility, waste processing, disposal if necessary, but also in that dark blue, that's the important part. That's the reuse, recovery, and recycling of every part and piece that can be recycled so that it can go back into, again, that full life cycle, go back into the manufacturing process, and manufacturers can then buy that raw material that's been recycled and use it again in their products. So again, the environmental product declaration, very, very thorough, looking at that life cycle. What they've done in Europe is kind of combine something that's in between the Declare program that we're using right now a lot in the US and the environmental product declaration, which is that full extreme. So CIPSE is the Chartered Institute of Building Services Engineers. It's basically the European version of ASHRAE. They're located in the UK. They set the safety standards, but they also set a lot of the sustainability standards for all of Europe. And they've created a standard called TM65 that basically looks at the entire life cycle of products, and it leaves out a couple of things that they've said, okay, manufacturers need to be responsible for a lot, but not for everything in the full life cycle. So this is again straight from that life cycles slide, but every category that doesn't have a white check mark, TM65, and over in Europe, they say you are not responsible, manufacturers, for anything that does not have a white check mark. So the maintenance of the product, the operational use of it, and also what's key there is they are also not responsible for what happens to the material after it's being uninstalled from the site and deconstructed at the site. So they say you have to build a product that can be deconstructed and can be recycled and used as a recycled material. However, you're not responsible for actually making sure that that material is recycled. So it's not perfect, but it is a nice balance where they're measuring a lot of the parts of the life cycle of the product. They're asking manufacturers to note and be transparent about where they're getting their material, but they're not saying that you also have to be responsible for what happens to the material after it's deconstructed on the job site. So it's a nice balance between the two. And this chart just kind of, again, compares the two, where you have the Declare label. Again, it's self-audited, but it has a very low barrier to entry. It's an easy way for manufacturers who have never really thought about sustainability or auditing their products to that extent to start the ball rolling on how do we create or measure carbon footprint of our products. So it's easy, but again, right now that's self-audited. It is based on the honor system, so there's a lot of loopholes. When you're looking apples to apples, it's very hard to compare and trust that every manufacturer is being honest about how sustainable their products really are. Again, the environmental product declaration is that other extreme where you definitely could trust what it says, but it has such a high barrier to entry. It'd be so expensive for manufacturers to do that we don't really see that as a realistic option in the United States either. Again, in TM65, what they've done in Europe is kind of a measure between the two. It's kind of a balance where they're leaving still some key areas out of certification, but they are at least auditing it, and they're making it something that is a little bit more valid so that designers in Europe, when they're choosing products, can, just like they do with UL, can choose, okay, I like this carbon footprint, I like this, I like this. Actually, in Europe, manufacturers now cannot be considered for bid on commercial products unless they have a TM65 rating on their spec sheet. So it is something that's starting to become more widely accepted, very much like we just take UL for granted right now in the United States. So where does the United States really need to go? For right now, we don't have any templates for testing. That's called a product category rule is the technical term for it, but it basically means that there is no universal template that each manufacturer can use when they're measuring carbon footprint of their product, or how sustainable it's going to be, or what happens to the material after it's been installed into the job site. But the importance of it is ISO standard compliance, that we have some type of digital template that, again, each manufacturer can test and manufacture the exact same way, so that you as designers, when you're looking at products and comparing and choosing which products you're going to use, if you are using something for sustainability in mind, that you can trust that they've all been universally tested and everyone is talking the same language. And also, we need a PCR that can also address regional differences. And that's something they've tackled in Europe. They have very similar issues on a continent that we have as a country, and that there are so many different municipalities with different standards, different laws, and different codes that we have to take into account as well. So let's look very quickly at an environmental impact report, because we can't really reduce what we can't measure. And again, universality is key there. So I'll take you quickly through an example of how to calculate an embodied carbon. So for this example, we'd use 4 steel screws. Each one of those components would weigh, screws would weigh 0.005 kilograms. To get the carbon footprint of those, you multiply them by a scientific standard called the embodied carbon coefficient. Basically, for steel, it's 2.97 kilograms per CO2 equivalent. And when you multiply that together, you get the carbon footprint of these 4 steel screws. In this case, it's 0.06 kilograms per CO2 equivalent. Now you can take that, the 4 steel screws, and expand upon it to a huge template like what you see here. This is a TM65 worksheet, something that they use over in Europe to measure the carbon footprint of a lighting fixture. So on this list, you'll see everything from aluminum, brass, copper, all the way down to iron, lithium, PVC, rubber, silicone, down to zinc as well. So this template is something that every manufacturer would get, and they would fill it out. So you have the embodied carbon coefficient is a scientific standard that's already there as a default. The next column over is they're actually asking you to measure the weight of each one of the line item components, or each material that you're using, by a percentage of the overall weight of the product, and also over here by the total weight as well. So you have to weigh the material in kilograms, and also how much of it is used as a percentage of the rest of the product. I'll explain why this is important in a minute, but they also ask manufacturers to include the origin location as well. So here you see a lot of United States, Canada, and China. Finally, here they also ask for the recycled content. You'll remember that the declare labels also ask for recycled content. And you'll see here on the spreadsheet that the only material that is used from a recycled source is aluminum, and it's about 30%. At the very end here, the last column, you'll see the embodied carbon coefficient for each material line item. And that is all calculated out. So once you enter your weights, you enter where it's from, and you enter if you used any recycled content, the spreadsheet or the template will give you this data over here, which is the carbon footprint for each piece of material. Then at the very bottom here, through a long calculation, it will calculate the overall carbon footprint for that product. And that is given in this dark green below. So again, it's just a template worksheet that you fill out how your product is made up, and it will tell you the carbon footprint of your product. So it's a pretty easy process to use. And why is that column that says the source material so important? And why do things like even the Declare program ask you to list where's your material originating from? And here's why. So this is a graph of new aluminum production. On the left-hand side, it's the power mix used to make the new aluminum. And on the right-hand side, it's just the size or the amount of new aluminum production. So China very makes a lot of new aluminum, but they also use a ton of power to do it using coal. In Europe and also in North America, mainly in Canada, we use hydroelectric power to create a lot of our aluminum, and the power mix on top of that is much less. Gulf Corporation, that would be natural gas, and also other Asian countries use coal as well. So when we're looking at the power draw, the amount of energy it required to produce aluminum, it is different depending on how it is produced. And so that is why where it's coming from and how, the manufacturing standards of those countries can be so incredibly important. But it's also important to note that just because something can be recycled doesn't mean that it is. So we keep talking about aluminum. Aluminum is used commonly in a lot of lighting fixtures, and it is ideal when we talk about sustainability because aluminum can be recycled infinitely over and over again. But even when we look in the United States, only about 60% of aluminum cans are recycled to date. And then when we look at other materials that are commonly used in lighting fixtures, like lenses and such, plastic bottles would equate to like a fixture lens or some other plastic components, and only about 20% of those are recycled. When we look at PVC, PCB that are used in LED boards, that's almost zero. So it's still a large challenge as far as how do we get those recycled pieces to a recycling facility. But here's why it's so important. So using and switching from new aluminum production to recycled aluminum can reduce the carbon footprint of products by about 94%. So this graph is showing the aluminum that's made by the global warming potential. And that's, again, going back to that one rating that I showed you, the life cycle analysis. And the life cycle analysis will measure the global warming potential of a product. And just by changing the source of aluminum of a product, you can change the overall global warming potential or carbon footprint by 94%. So it is very important, again, to look at the source material of those as well. And if you will really care about if you're looking for manufacturing partners specifically for those eco-friendly projects, then also looking at where they source and how they build is so important. So in the United States, where are we going with all the sustainability? So first of all, energy consumption is always important to look at. This is a graph looking at some older data, and this starts in 2003. So I started in the lighting industry personally in 2005. So I'll give you a little personal anecdote. This was back way before LEDs. We were using metal halides, a little bit of compact fluorescent, some incandescent and regular linear fluorescent fixtures. At that point in time, a typical commercial building was using about 38% of their energy in lighting alone. Fast forward about 9 years to 2012. This is when LEDs were out there, but they weren't necessarily being universally used everywhere like they are today. If a municipality or a city's energy was cheap, people were still using fluorescent fixtures. They didn't care about switching over to LEDs at that time. So it was still very mixed as far as what type of lighting sources you were finding in buildings. But even with that slow adoption, we were able to reduce the overall energy usage of lighting from taking up 38% of a building's energy to only 9% of a building's energy. And that's just from switching light sources alone. We know that since then, that number has continued to decrease just as technology and controls have gotten a lot better. And we see the lighting industry as far as, again, sustainability standards very much the same way. In the early days of those LEDs, there were a lot of standards that had to be developed so that it was going to be widely used. And we think sustainability is very much in that same early stage. There is something called, again, cradle to cradle. You saw the logo at the beginning of the presentation in all of those sustainability standards, and you might start seeing this a lot more on spec sheets as well. But basically, again, it's looking at that full life cycle. It is an idea that any manufactured product should follow the same organic life cycle that nature does. But in a whole, it has us looking at the full life cycle of products. To do that, to go with the circular economy, again, you have to be very stringent about what happens to material at the end of a product's life cycle. So once it's taken off of a site, who is going to be responsible for taking the product apart and sending the different parts and pieces to either a landfill or to recycling facilities? A lot of places and a lot of the answer, this is a big question that has not been answered yet, to be transparent, but one of the big answers is we'll send it back to the manufacturer who made it and let them do it. That's called a take-back program, and it's a logical answer to it. It's not necessarily, again, the perfect answer as well. That's why I say there is no perfect answer to this at this point in time. A couple of drawbacks. The big benefit to the Take Back program is that you have an answer to whose responsibility is this, and who can we make sure is going to disassemble the product and make sure that those recyclable components are recycled. The couple of drawbacks to it is that you have to now take into account the transportation of that material back to the factory when you're looking at the carbon footprint. So it's just one more step in the process that can add to the carbon footprint of the product. You also have to account for current laws and standards that actually in a lot of states right now, take-back programs for manufacturers are illegal. So a manufacturer is not allowed to take or accept their old products back, disassemble the parts and pieces, and send those out to recycling facilities for profit reasons and other reasons. It's considered a conflict of interest right now in a lot of states. And I won't go into detail about which states are which, but a lot of those states are where a lot of manufacturers are right now. So it's a mixed bag of whether this can work in the current state economy right now. So there are a lot of questions that still need to be answered while we're developing these standards. A lot of those have to do with, are we also creating the rules and regulations that will allow for responsible recycling initiatives once we have these sustainability standards in place. So with that, that concludes the entire CEU portion of this. I think Sam was going to open up for questions. I'll be happy to answer.